Alright class, it's been a long weekend, went to a couple restaurants, but today we're going to learn about some geometric sequences. The formulas you need to know are
when are we going to use this in the real world?
Let me think about that for a minute. Okay. So, a ball is dropped from 16 meters and bounces 80% of its previous bounce's height each bounce. How far will it cover before it comes to rest? You guys try and work it out and we'll go over it in about 10 minutes.
Forrest, can you help me? I don't get this.
Once I figure it out.
Okay.
I hate this song. I don't believe that anybody else feels the way you do about this song. Alright, so let's go over the problem. So, your ball is going to start out at 16 feet. So that's going to be your A1 value. And then it's going to go 80% of its original height each bounce. So that's going to be our R value. So we can plug it in to the sum of an infinite geometric series. So our formula is going to be A1, which is 16, over 1 minus R, which is 80%, which is going to be 0.8. So that's going to equal then, does anybody have a calculator?
It's 80.
Thank you, Eli. Okay, so this 80 is going to be our total distance from its first drop. But that's only accounting for the distance we travel going downwards along the ball's path. So our graph of motion would look like this. And we're going to only end up with this formula calculating for these down distances. So we need to multiply this 80 by 2, which is going to equal 160 feet. But then that's accounting for the fact that we went up to our original height. So we're going to need to subtract our original height from this 160. So we're going to get 160 minus 16 equals, does everybody have a calculator?
It's 144.
Thank you, Eli. And that's going to be our final answer. Mr. Anker, if gravity was doubled and someone stopped the ball from bouncing after 4 bounces, how far would it go? Well, as a physics student, you should know that doubling gravity has absolutely no effect whatsoever. But good question, Forrest. So, for this one, we're gonna have to use the sum of a finite geometric series. And the formula for that is going to be A1 times the quantity of 1 minus R to the n over 1 minus R. And our A1 value is going to be 16 because that's how far our ball was dropped from. And our n value is going to be 4 because the ball bounces 4 times. And our R is still 0.08. So written out, it should look like this. And this is going to simplify down to a sum of, let me think, 32.768. And then we're going to have to take this number and multiply it by 2 again, because we got to find downwards motion, and then subtract A1. So the answer should be 49.536 feet.
That 5 is terrible.
At least my circles are good, Eli. Alright, so on to the next problem. I want you guys to find the 8th term of the sequence or formula a to the n equals 6 times 0.9 to the n.
Mr. Anker, I don't understand.
Alright, Sarah, since it's so difficult, I'll just do it on the board.
Mr. Anker, there's no negative sign right there.
Can I just do math without you breathing down in my neck all the time, guys?
That's a piece of candy.
But I guess you're right.
Penis.
Alright, that concludes our lesson for today, guys. The homework's on the board. Just try and stay busy. And remember, kids, wakeboarding is dangerous.